So basically this entire concept is coming, Docker concept is coming recently, right? When this DevOps is very much popular. So when we're talking about first thing, you guys are already aware some sort of a technology concept, right? If you are in terms of Java, if you are talking about any development language which we are using into a for any sort of what we can call as, if you are talking about web application, if you are talking about any other servers as well, right? If you are talking about any installer as well, right? So many such things if you talk about, right? So everything is basically, right, we are, let's say if you are talking about, if you wanted to set up a database server on your machine, so what you do, you search for that installer into a particularly on Google or maybe on the site MySQL or Postgres. You download the installer, you install, and then you will try to create some schema, ID, password, and everything, and then create a schema, and then you will connect to a particularly on the server, so database server, correct? But in the same way, if you wanted to do any setup for Node.js, or if you're talking about any particular application setup for Java, in terms of what you do, basically you down set up that all this Java environment, Eclipse, and then you will start writing a code, correct? Then there is a packaging you do, either you create a var, or if you are creating a jar executables, or then deployable like this, and or EAR, then you will, if it is a web application or enterprise application, you deploy it on the Tomcat. Once, so how to deploy the Tomcat? You basically, Tomcat is a free server, that's why I'm just taking a name. Either you can deploy on JBoss or any other place also. So what you do, you download it, right? And you also set up that Java environment. Then you need to set up that particularly web environment, and you can say server environment. Then you will deploy and then run the application. In Spring Boot applications, you don't need to set up that server and everything. This is an embedded Tomcat server is there. So when you run it, it will be automatically getting executed. Correct. So that's the way basically we do it, all this setup. Let's say in enterprise, or maybe if you want, if you go into any particularly firm, so in the firm what is happening is it's a very different team has a different ownership. There is an infrastructure team. So if you need any machine apart from your local machine, let's say for any UAT integration, for any testings like that, so you request the machine. So they will give it, either if you need a Windows machine or Linux machine, they will give that particularly machine. It is a nothing but a VM, correct? On the VM, basically once it is got allocated, so then you will start doing a setup and installation and everything, correct? So what you do, then you will get that server and everything, you will copy on that machine, either through putty or whatever, or maybe it's a Windows from some shared drive or something like that. Then you will start doing a setup on the machine, correct? Then you will deploy the application. So let's say if you are basically, that is a one thing. So everything is basically you need to do an installation, setup, and everything. Now if you are talking about particularly application, enterprise application. So enterprise application, let's say many such people, they have developed their own frameworks. Some people are in the framework and there are some configuration are there, property files or so many things. Then there is some database setup. So these database scripts also getting executed when the boot up of the application. So in that case, many such configuration required, setup is required, then you need to do some tuning and everything, then your application will be up, right? That is a basically major challenge. Now there is so many other things if you are talking about monolithic and microservice architecture as well, right? Because monolithic applications, you can go through the particularly complete video, right? When we are talking about monolithic applications or microservice applications, or the architecture wise, basically the differences, pros and cons. So many such these problems are there. But when we are talking about particularly these deployments, and it is a really challenging. Now let's say you are a person that others has developed that particularly application, and he's saying that okay, and there are some more people wanted to deploy and set up on their own machine. So if there are enterprise application, there are many such frameworks and other thing, configurations and scripts you need it, how you will do it? So then every person has to follow some readme, or maybe there is some particularly local setup guide. So most of the companies, these developers are facing so much challenges. Legacy applications are still on the monolithic architecture. So there is so much challenges because the people do not able to set up that everything on their machine. First thing. So this testing and then local development is also very challenging. Correct. Apart from that, if you wanted to move this particularly running state for your application into a next environment. So how you will do it? So what we do generally, let's say if you are fixing any bugs or like that, you generally create that particularly, let's say var or AR, you will give some naming conventions, or this day it is with these features we have created. But if there is a some environment different or something are different like this, in that case still there is a so much challenges, because that moving from one environment to another environment, if you are sharing this particularly image of working copy into with some other developer, that is a very challenging here. So basically that developing, shipping and the running application, these are the 3 steps. So these steps are really basically making so much impact, correct. So now in that case, what are the challenges? So earlier days, there is a basically we have that if you wanted to have an integrated environment, when we are talking about integrated environment means multiple people are working as a into a development environment. So many people are working on 2 common tasks. Let's say we hired a 60 people team. Into a 60 people team, some are working on the UI, some of these working on, let's say, some one module, other are working on other modules. They are continuously doing a development. Some are working on common files. So it is very hard to get that working copy. Sometimes it is a basically how you will review, how you will do it. All these things are really challenging. Correct. So in that case, how you will basically make that error prone copy, correct? And another thing is that there is no such human interventions required. So how you will make that a particularly things like that. So there is basically a build team. Now earlier we have also used that particularly a Maven, right? So Maven, Gradle. Now if you will see, if you are using a particularly in a scripting side, NPM is supporting a much more is a major area where we can have a NPM this package manager. You can get that package download and you can just run some NPM commands and then you can build it, correct? But still that for after development for shipping and you can moving to some other environment, and when you are giving that per working copy to some other people, these things are really challenging. Correct. So how you will make that very streamlined process, and how you can make sure that, right, this copy is, there is no such changes into this copy, and if it is working into this place, it will also work into some other place. Okay. So when we are talking about, when we are saying that if it is working into one place, it will also work into in some other place, correct? So in that case, we need to have particularly a system, right, that so that if there is there should not be any manual intervention required, and if this copy is working into one environment, then this copy will into other environment. Point number 1. Point number 2, you are doing everything is basically you are downloading the executables, then you are executing, then you are doing the setup and all these things like that, correct? So rather than to do all these things, what we do, we basically do a run that create that environment just from that particularly a configuration file, correct? So you can create this entire environment just from one configuration file. So you don't need to install the Java, you don't need to run all these things. Maybe you need to do a complete setup, setting the environment and everything like this. From the configuration, you can just do each and everything, correct? So there is a concept basically for a VM and the container. So that is also we will coming into just later here. First thing, earlier days, virtual machine, right? You can create a multiple VMs on the same particularly hardware machine. So generally people, what they do is basically you can have one large machine where you have a CPU processors, very heavy CPU and heavy machine for that. If you're talking about storage, memory and RAM and everything, you can create a multiple VMs over there. That's the way the industry works, right? So that is the concept. When you are requesting any machine, so they just create the VM and they will give it to you. That is the process earlier people follow. But now we are moving into a container. Container is nothing but it's a basically a separate isolated box where this application will be running here. So you can have a multiple containers can be run, right? So this multiple container, each container can be, you can say if you are working as for, let's say, Java container, right? So Java container, you can have this Java app can be run in one container. If you have a database container, you can have a separate database container. This database will be running on through a separate container like this. So you don't need to install, set up that complete server and everything. This will be shifted into a basically into a container concept. So Docker is basically helping it to us for this entire concept for containerization. So you already know, right? If you see the sign of the Docker, it's nothing but like a ship. So when you are basically shifting any particularly things from the ship, right, you will have that different containers, right? So you will see into a ship, basically a good ship, what we can call is, right? So you will see multiple containers, right? So there can be different things into different containers. These containers can be put in into a ship, and this ship will be go from one place to another place. Correct. So that's why this entire concept of coming is from that containerization. So Docker is an open platform for developing, shipping, and running applications, right? Enable us you to separate your application from your infrastructure so you can deliver software quickly. So basically, when you are talking about particularly your application will be completely separate from your infrastructure, right? Now you can manage your infrastructure in the same way, manage your application. So there is a many such other things also, which we'll also discuss here. So Docker platform. So that is the whole and soul. I have just given an idea what are the challenges people face earlier before that, particularly when we are talking about we are not using the Docker, right? If you can just check with some of your friends who are working without, some of the companies are who are already not using the Docker, some legacy application where people not using the Docker, they will tell you exactly where these are the challenges. Correct. So Docker provides the ability to package and run your application into a loosely isolated environment called as a container. So as I told you, it's a virtual sandbox where your application is completely working, and it is a completely isolated box here. So the isolation and the security allows you to run many containers simultaneously on a given host. So one host, you can have multiple containers, and these are much more lightweight. Okay. So, and the contain everything need to run the application. So generally, if you are creating a container, let's say if you wanted to create a container for Java application and the database application like this, if you wanted to run, right, let's say two-tier application. Correct. So here, if you have a particularly Java application and the database application, so you will create a Java particularly container. There is a database container. Two container can be created and can be run on the one particular host. So you do not need to rely on what is currently installed on the host. So there is a nothing is required if you got that blank host with just an operating system. Even though if you are create that Ubuntu also from the image itself, right? So just like you are downloading installer, then you will run that, then you will set up, then all these things you don't need to do it. Correct. So directly you can download and you can run the image. The image can be downloaded from that public repository. That is something we call as a Docker hub, and it can, you can create that entire container. Correct. So you are not worried about it, what is installed on the machine. You can install and then you can run that on the particularly machine here. Okay, that is the basically very powerful advantage here, right? Even though into a DevOps concept, many other things, one level up, I can tell you, if you are basically using the particularly a next concept into orchestrations, and you can also create an infrastructure also with the help of Terraform, and there are some other sources are also infrastructure also you can create just to specifying some sort of a configuration. With the help of configuration of file, you can create an infrastructure like this. Correct. So now the industry is moving like this, and these same concept people are using into so many long. If you will just check for particularly AWS, so AWS, GCP, Alibaba, all these are basically majorly using this concept behind the scene. Okay, so Docker provides a tooling and platform to manage the life cycle of your containers. So how you will manage that particularly life cycle? So develop your application and it's supporting components using a container, right? So containers become the unit of distributing and testing your applications. So if you are wanted to test your application, right, and if you wanted to create particularly a distributed environment also, that is also you can just do it. So when you ready deploy your application into your production environment as a container or as an orchestration service, these things also we will can get that particularly help from the Docker. Correct. So Kubernetes work on top of the Docker. Okay, so this works same whether your production environment is a local data center or it's a cloud provider or it is a hybrid. Hybrid means when you are Some of the services are running in your own environment, some of the services are running your basically into a cloud environment. Correct. So when you are moving, that's why I told you, right, that is a ship is going from one place to another place. So entire thing shipping is very easy when we are talking about. So you are not bothered about it, what is available on the machine or not. This entire environment you can create it, and basically it is nothing but we are creating a containers. These are basically an isolated box. Okay, so earlier what we do, we need to set up that entire environment, then you need to run some script, you need to do a configuration, you need to do some boot up script, then you will try and see still if there is some compatibility issues between your jars. Let's say if your application is running on Tomcat or JBoss, some particular version, let's say 7.2 or something like that, but on that particular host is this 8.0 or Wildfly you have installed, then maybe you will see some of the compatibility issues. And if there is a particular, let's say you have developed your application in Java 5 and you are planning to deploy into a Tomcat some other version that is not compatible with Java 5, then still you will face some challenges. So then people so much struggle for this compatibility issues and all this environment setup and so many things. Correct. So that is we are not bothered about it all. Correct. So what when we are saying that we from that particularly you can say configuration file, we will basically create that entire container. Correct. So that is this all about. What can I use Docker for, right? So fast, consistent delivery of your application. So Docker streamline the development lifecycle by allowing developers to work into a standardized environment, right? So using the local container, which provide your application and the services. So containers are great for continuous integration and continuous delivery. So basically now everybody, you know that, right? I hope that you are aware about the Jenkins. So basically in Jenkins, also, if you will see, so Jenkins also, if you will see, there is a CI/CD pipeline, correct? So every company is using that CI/CD pipeline, and then these CI/CD pipelines are basically used for getting that source code from your version control. Then you will build, you will do multiple other things, then you will deliver, right? So that is the basically CI/CD pipeline we set up into a Jenkins, correct? So in the same way, we create the container, and it is a basically without any human touch. You can just, if this particular state or this application for that particularly, you can say generally what we do, we have the particular branch where you do the source code checked in and you will do some labeling. So once the labeling is done, you will create that particularly a build, and then it will be, you will run it, right? That's the way we were, if you are talking about particularly creating a jar, if you are creating a var also. So in that case, when we are particularly running that, so rather than to create, so we, even though still we create a jar and var also, after that we create an image. Okay, so still it's nothing like that directly your code and you are creating an image is nothing but a basically a configuration file. With the help of this configuration file, we are creating the environment. That environment is nothing but your container. So you can create a multi-containers or multiple containers also. With the help of Docker Compose and all other things, you can create a single container also. If you are creating a container for your Java application, you can use that basically a base image of Java. So because for Java application, you need that to build that application some base, right? So for that, you need to have some Java environment. So base image, you can fetch it from your, particularly from Docker Hub, and from your code can be, you can get it and you can just run it, right? So let's say if I'm saying I will give it, I have created some Java applications or that use this Java and execute it on your machine. So to run this Java application, you need that runtime. So generally what you do, you will install that particularly JDK and then you will run it. But in case of if I will give the image to you, correct? So that image will be basically, you don't worry about it. Either you have installed or not Java or nothing else. Once you will just run the image, it will be basically complete environment will be getting done. And for running this image, you need to have this Docker on your machine. Okay, so that is the basically whole and soul the ecosystem works like that. Okay, so the following example scenarios you can understand here. The developers write the code locally, share their work with their colleagues and using the Docker container. So what you do whenever you are doing anything, so you can share that whatever you had done it, you can create the image and you can share it. So they use Docker, push their application into a test environment, execute automated and manual tests. So when you are basically create an image, that image you can run and create the container, right? and basically you can run some automated test cases, whatever environment has been created from that your image. So when developer finds any bugs, they can fix them into development environment, redeploy them using the same concept, create an image, and then you can run that test and do some validations. Correct. So this is the way basically this Docker will help to you. Okay. Base thing, you can note it down that even though you don't have anything on setup on your machine, still you can run your application with the help of Docker. Correct. So responsive development and the scaling is also very helpful. So Docker container based platform allows you a highly portable workloads. Portable means you can carry from one place to another place. Otherwise, earlier it was very difficult moving the environment from one place to another. Okay, so Docker container can run on a developer's local laptop or physical or virtual machines in a data center, on a cloud, or any other environment, because you are not worried about it, what type of environment it is. So if you are running the same image, it can run on my machine, irrespective to what is the version I have, what are the things I'm not cared about it, right? If you are using this same image into going into a EC2 instance or AWS or some other places, still you are not bothered about it, what is installed on that machine, because there is you're not bothered about this entire environment we are creating from the and using these container concepts, right? So there is a complete dependency got basically we have removed it, right? Earlier there was some human error also. You have some installed, you have done some installation, it is not correct. People are trying to do some deployment, they are facing some challenges. Then one person is coming and fixing is. These are also another challenges. So these things are completely gone off now. So the delivery is much more faster. So now responsive deployment scaling. So Docker portability and lightweight nature also make it easy to dynamically manage the workloads. Scaling up to or tearing down applications. So that is also we can achieve it, right? So we can also scale the applications. Okay. So there is a concept for horizontal and you can say vertical. So here what we are talking about here, we are talking about the horizontal scaling, not a vertical. Horizontal means you are creating a multiple replicas. Okay, like that. So running more workloads on the same hardware. So Docker is lightweight and fast. It provides the viable cost effective alternative for hypervisor based virtual machines, as I told you, right? VM concept. So these are much more benefited as compared to VMs. So you can use, right, more of your compute capacity to achieve your business goals. So generally, if you have a, let's say, very heavy virtual machine, but your application is not consuming everything, so that your basically hardware is got wasted only. So you can much better ways you can utilize it. Okay, so that is a basically also a better utilizations and better resource utilization for purpose. Also, it is a really very helpful to us. So how this Docker architecture? So generally we have, there is a client, there is a Docker host, there is a registry. So there is a Docker is also coming into an enterprise editions, and there is a one Docker is generally what we are using for community editions, which we can use it for our development and the learning purpose. Okay, so when we are talking about community editions, right? So we have the Docker client. Docker client, let's say if you are running into connecting from your command line to some other, also your basically command line will behave like a client, right? So in the same way, here is also we have the Docker client, right? So whenever we install that particularly complete Docker through installer, right? So we will also get that client, and there is a Docker hub. So Docker hub, right? It is nothing but it contains that particularly a Docker daemon and the container boards. Basically, how the Docker daemon works, that is also we'll see. So Docker uses the client server architecture. The Docker client talks to a Docker daemon, right? So this Docker daemon should be also running on your machine, which does the heavy lifting of a building, running and distributing your container. So this everything is all about this Docker daemon. So Docker client is nothing but it is just helping you to connect to a particularly a Docker host. So Docker client and daemon can run on the same system also. And you can also run that particularly a Docker client on some other machine and Docker host on some other machine, right? If you have a really a managed environment kind of. So you can connect a Docker client to a remote Docker daemon also. Let's say if you install your Docker onto an AWS or any other shared environment. So on that, from your local machine, you can connect to a Docker, right, daemon. From that Docker daemon, then you can build and you can just do it. Else, you can also have that Docker daemon and Docker client on the same machine. So the Docker client and daemon communicate using the REST API over the Unix socket or a network interface. So they communicate through a REST APIs. Another Docker client is a Docker Compose. If you wanted to go with the multi-container setup, right? So Docker Compose, we are using it. That let you work with the application consist of a set of containers if you wanted to have multi-containers. So that is a difference between a Docker Compose and the pure Docker. So now when you are installing any Docker desktop, right? Docker installation, when you do it, so you will get that client and this Docker host both, so that you can run your Docker commands from your command line, because this Docker client is also got installed. Docker host, because this Docker daemon is running on your machine. You will see this Docker, whenever you will see there is a one ship icon in your C into a right hand side downside corner, you can see where you can find out the Docker, or you can also check for a Docker desktop and you can just find out. Okay, then there is a concept of a registry. Registry is nothing but there is a basically a which is used for storing the particularly in images. Correct. So Docker Hub is a public, right, repository where you can have these registries are there. This is the basically icon of a Docker. You will see once it is what installed here. So when we are talking about particularly a registry, so this registry is basically you need to understand, right, how this registry. So you can create your own registry also. So you need to create a particularly account onto a Docker Hub, right? So you can just basically log in and you can create your own Docker Hub where you can upload and you can say get the particularly images. Another thing is that more public images are already there. There are some of the images you can also make your image publicly. You can upload to Docker Hub, any application, anything. Many freeware sources, free softwares, images are already there onto a public repository. Okay, so these you can directly Java 8, Java 9, MySQL, Postgres. These are the some kind of what we can call as these images are already available. Correct. So Docker daemon we have used, already discussed. Registries we have used it. Docker object. When you Docker use the Docker, you are creating and using image containers, networks, volumes, plugin, and other objects. So what is the images? Image is a real-time only template that instruction for creating a Docker container. So I already discussed and told you what is an image. Often an image is based on the image, another image. Means when you are you can say running your Java app, so you are creating your image. This particular image is dependent on, let's say, Java. So you are also depending on the Java image like this with some additional customization. Okay, so let's say if you build an image which is based on the Ubuntu, but installs the Apache web server and your application as well the configuration details needed to make your application run. Correct. So like this, so you can also create. So there is some commands also. Else you can create a Docker file also. Docker files with the simple syntax, and you can specify some of the steps, just like your Windows batch command. Correct. Copy, then you will run some command like this. This is just like that batch command. You can create a Docker file. With the help of Docker file, you can create an image. You can also create an image with the help of some commands also. That is also you can do it. Containers, right, is a runnable instance of an image. You can create, start, stop, move, delete a container using the Docker API or a CLI. API means you can also connect to a API through web interfaces, or CLI is command line interface, which is basically which we are talking about. So by default, the container is relatively more isolated from other containers. These things we have already. So now, if you wanted to run any particular image, generally we use the command for Docker run. There is some switches -i -t. These things we will discuss later. But as of now, you need to understand that this is the basically a image name. This Ubuntu image is already there. Correct. So you need to understand how particularly this image is used for. Right. Now, if you will just say these are the basically overall concept here. correct? But if you wanted to just see how to getting started, you need to download and setting up basically a particularly a Docker, correct? So you can just come and you can see here, right? First you need to install, download that particular installer here, download that particularly, you can click into Windows, right? Once you are, so you see this Docker desktop is getting downloaded here, right? So once it is, I'm just pausing here because we already have into my machine, right? So once you will get it downloaded here, you can directly execute it. Okay, once you will execute it, you will see, right? So it is a exe, double click, execute it, and it will be getting installed on your machine. Okay, so how it will looks like, and you can just put it into a start programs, right? Start bar, and you can search for Docker desktop. If it is getting installed, there is a zip icon, you will see Docker desktop. Okay, so this exe you can download and you can double click it and just run it. Don't need to do any such changes here. Just click next and then complete it. Okay, then I will show you how the Docker desktop looks like. Okay, so this is the way this Docker desktop looks like here. So these many apps I already have into my machine, right? So this, that's why you are seeing these many images. It is running or not running or something like that, correct? So containers and apps, right? These are the containers. Basically, I already run it. These many images you can see, right? So local and remote repository also. So this ch Ashish is nothing but is my repository, and it is nothing but my Docker Hub ID. So basically you need to create a Docker Hub ID to use this Docker particularly, right? So whenever you are installing and you are running it, you also need that. So you need to create one user ID onto a Docker Hub also. So this repository is nothing but my Docker Hub ID, where I have put these many images. Now there is a volumes. Volumes are nothing but something we call, if you are giving any additional data or things like that, these are something we call as a volume. Let's say if you wanted to use some particularly database script for creating an schema and tables before connecting to a database server, so this database script is nothing but a volume. So volumes are basically, you can create a volume so that, let's say if you have deleted the particular container, but still your data will be getting saved. So next time if you are creating a container, same volume you can attach it. It's a very powerful concept, right? You can just note it down. So let's say if you have a particularly a container for logs, right? So these logs can be available into a particularly as a volume, as a data. This can be, let's say if you are just doing any particularly a container which is aggregating the logs, right? So you are doing some massaging onto a logs, getting some relative reports or something like that, or you are doing anything. In that case, what you can do it, basically you can just use that particular volume and then you can attach it, right? So there is a many such setting up. You can just use it, attach the volume, specify the directory and these things, right? So it is a really very, and you will see this is a basically a enable running here. You can just see this Docker running here. This is a Docker icon. This is a Kubernetes icon also. It will ask for you, so do you want it to run a Kubernetes also? Because single node Kubernetes setup also you can run it. So you can see that restart like this, support and all these things you can see, correct? So this is the way the setting and everything, you can just see it here, right? Now if you wanted to just go into a particularly this is our app here. So this is a very simple Spring Boot app I have developed here. So you don't need to, there is a 3 ways you can create a Docker, what we can call as particularly image Spring Boot app. So one thing is you can create a Docker file. I have already explained it to you. It is a setup command. So this is a simple Spring Boot app, whatever I have just created, and this is a simple REST controller and the mapping here. Nothing else is there. So with the help of this Docker file, so there is one simple Docker file. So we are from this OpenJDK. We are using this OpenJDK Alpine. It is a lightweight, so that's why we are using this particularly image. So when we are basically using this image, we are basically getting and we are using this Java 8. Now, so what we are doing it, Here we are just taking up this particularly a jar file. Whenever we are running and building this Spring Boot app, let's say if I will run that mvn clean install, so it will create a jar file inside the target, right? That is a basically okay. So when we are running and building it, particularly the jar here, so we are right adding here, okay, from target like this, and this is the entry point is nothing but there is a command. So we are using java hyphen jar like this. So this is a very simple particularly a command, right? Any jar if you wanted to execute, that is the way we run it into a java file, correct? Java jar file, right? This is the way you can run it and then you can execute it. This is the, there is a many such more syntax are there, but I'm not covering so many things here. You can just try to understand these many things and you can just run it, correct? So now if you wanted to go for this particularly copy here, right? So you can find out the particularly properties. So you can go where this docker file is there. So it is available into this directory, right? And you can go into a command line, right? So you can just go into a command line here. What you can do, so it is using a basically, this is a basically a command for docker build hyphen t. You can give the name and the dot here. So I will explain it to you, right? So this is the way the image has been created here, correct? So if you will see if this docker is successfully installed here or not, you can see docker. Oh, sorry, right? You can see docker. Now you, if you wanted to basically, you also you need to use and connect your command line. Also this is a nothing but our command line is nothing but a docker client which is connecting to your docker daemon. So docker desktop consists of a docker client and docker daemon both, right? So this is the way you can see, if you number of images, whatever the images you have, you can use that docker images. Many such images you can see. These many images are available on my local, right? There are some images on my remote like this. So there are many such other commands are there, right? But I'm just trying to help it to you run this particularly uh, what we can call as particularly that image. So what, which image we have created as of now here? We have created the image name was, this is the image name. Test image is the image name. Okay. So hyphen T and dot, I will just explain it to you. So let's first use that docker run. P 6 test image. Correct. So this is nothing but we are just mapping here. If you wanted to run this particularly container here on 8081, you can use that like this. So what is this application is running on 8081 or like this. So there is a host port is different and the container port is different, right? So you need to map your host port with the container port. That's why we are using a hyphen p and we are specifying this mapping with the port. Okay, host port and the container port, not just an enter. Okay. So you see now this Spring Boot application is running here, right? This is the way it is running here. So you need to check this once this application, now this container is running. Now you can check it and then you can just manage it exactly. Basically, correct. So you will see this container is started and it is running. So you can verify your particularly REST endpoints, and you can also verify through just go to your browser and check it, right? So there is no such error is there. Everything is running and working fine here. Okay. So this is the way you can running. These are the basically some commands into my main Spring Boot application. I have put it down. That's why I'm running here. So now you have run it. So you can verify this your REST endpoints and you can just check it, right? So you are also see we have created our image also. You can find out when you are running into a Docker image and you can process and you can see. Okay. So this is the way you can just see. This is the very, I guess I have tried to explain it to you multiple things, but still you guys can tell me if you have any such questions or any other thing. So I have another 5 minutes. I can answer it to you. Any questions? Hello guys.
No,
Huh?
no, sir. I'm good.
Others? Okay. So if you don't have any such questions here, then it's okay. I can just basically close it here. And if you wanted to see uh, into a browser, you can just go and see into a browser here. Six.